Hello, hi! This is our final programming exercise video of the boot camp. This is exercise 4 of CST 341. This is a myriad of Java exercises. And I guess we'll go ahead and get started. So this is going to be number 1. Basically, it was a Stack Overflow issue where we ran out of memory. Essentially, we were just to fix it so that it would not run out of memory anymore. So the fix for that was just to change line 5 from exception to Stack Overflow error. And then, when we actually run this, we do get catch and then out. It does eventually stop. So it's not overflowing as it was. Number 2 was a string builder initialization. Question what does this code print and why? Go ahead and print it, but it prints as 0 with another 0. Why? Well, it's because SB is empty. We never added any characters to it. Number 2 is why would a programmer use new string builder 100 instead of just new string builder? And the 100 is setting the initial capacity in order to allocate memory needed for it as well. Basically allocating the memory for it prior to actually needing it, so it's not having to allocate it later. Number 3 is endless loop. So essentially, this one would just print 1 endlessly. It still does print endlessly. So the question on this one is explain why code never stops printing 1. And it's simple. The check and increment, the scope of the increment is limited to this method only. X equals 1 is a constant basically, and it never gets changed. So no matter what, it's always going to be 1. And as far as the the main method's concerned, it never gets updated. Let's see, this is number 4. So we want to show and explain what this prints. Okay, so let's go ahead and uncomment this, and then run this. And so yeah, we get 0.1020 and then 0.020. Main reason being is X is on the wrong side of the equal sign here. So lines 19 and line 20 are directly calling X here and assigning it, but what's happening is it's making a copy of that. Up here in this method on line 5, the assign method, it essentially is saying that the original X is this dot X, where that's the original is a copy, whereas the copy is a copy of the original. The fix for that is just to, reverse X, and this is X. And now we get, what the intended, result would have been at that point. Number 5 is 2D arrays. So essentially, the syntax error on this is you're setting the basically setting the dimensions of a contained array without setting the dimensions of another contained array. Because you're trying to specify that this one's only going to be 8, and the compiler sees this as going, well, I don't know how many you're going to have. You could potentially, ultimately, you could have less than 8, and that would be obviously a problem at runtime. So the logical fix obviously is just to set the initial capacity. I mean, and if you know your second one's going to be 8 as well, then you just set your second dimension capacity, and then that's perfectly legal and acceptable there. Number 6, basically we want to know what is removed here. So originally, this is the code. Just based on this, it's gonna pull the 0 out. Line 13 is written in a way that is, so basically list.remove can remove based on the value or the index. And the way they have this written is it's basically integer.value of, you put what value you're looking for in your list, and in this case they use the 0, and it will fix that index within the parentheses for remove. So the the index for 0 in this case would be 2. So it's going to list.remove 2 essentially. And I mean, if we put a 1 here, we'll see that it'd be 2 and 0 left because it's removing index 1 at that point. If we do this instead on line 12, right, we're gonna lose our 2. Actually, no, we're losing our 0. Sorry. This is the one I was thinking of. So if we comment these out, we comment this guy back in. Let's see. So in this case on line 10, what we're essentially assigning is a value of I, event I, to be the index of value 0. So the index of value 0 in this case is 2. So that would be 2 in that situation. We've already covered the removal pretty much on that one. And then the next ones are 7 and 8. I combined them into 1 because I didn't realize there was an 8. So this is number 7. So we run this, I think, that was originally there. So we get false, 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 true, false. So basically we're on line 7 comparing a string to an object, and no matter what you put in between here, it's not going to equal, or it's not going to see it as being equal. And then here we're just doing the opposite. We're comparing an object to a string. It's still going to be false. Here we're comparing two objects with the dot equals, and I believe this is meant for I think this is more meant for something else. I don't know if I do this. Probably not going to equal. Probably still be false. Yeah. So, well, I know why it's still false. It's because they're two different memory locations. So dot equals, if SB2 equaled SB1, so if we didn't do this right here, and we did this instead, then we would get true, because it's sharing the same memory location. But since it's not sharing the same memory location, it will always come up as false. Line 9 is only passing true in the first portion because we're converting the object over to the toString method, which basically converts the contents to a string. And we're comparing a string to a string. And then again, SB dot equals str, but we're doing the same thing we did in the first one. We're comparing an object to a string, and that would not work. Let's see. Okay, that was number 7. This is number 8. So we get the answer of false and true. So again, these are two different memory locations, and essentially we're not comparing the actual string values here. We're only comparing whether the objects are equal or not. Again, if we were to do something like this, then we're going to get true on both. This is true because this is actually this is comparing the actual strings of these objects directly. But yeah, my side notes essentially are kind of the same. S1 and S2 are two different objects. When you use the double equal operator, S1 and S2 comparison, then the result is false because both have different addresses in memory. When using dot equals, the result is true because it's the only comparing values of S1 and S2 at that point. I believe that's going to do it. There's no more for now. Well, I guess do it for good. So until next time, ahui ho, olama pono.